Welcome to another video. In this video, we want to solve a question on dimension. So this particular contest involves the connection between the period of oscillation, the length, and the acceleration due to gravity. So represented in this equation. The period of oscillation of a simple pendulum is related to its length L and acceleration due to gravity G by T is equal to 2 pi L raised to power x G raised to power y, where x and y are constants. Find the values of x and y. Hence, write the formula connecting T, L, and G. The first thing, whenever you see this type of question, the first thing that comes to mind is that we are going to rewrite this, then we expand. So the solution, then T, the question is T is equal to 2 pi L raised to power x G raised to power y. And we should bear in mind that 2 pi is a constant. So we don't need 2 pi in dimension. This is a scalar, so we don't need it in dimension. We only need the variables. So how do we go about this? So we now rewrite this as, because this L represents the length, G represents acceleration due to gravity. So we know that T is now equal to, now we are going to remove this 2 pi because it's a constant. We only need L raised to power x and G raised to power y on the right hand side. So that implies that L raised to power x, then G. How do we expand this G? It's very simple. The unit of acceleration due to gravity is ms raised to power minus 1 minus 2. That is meter per second squared. That is the unit of acceleration due to gravity. So the next line of action is to write the dimensional symbol for G. How do we get the dimensional symbol? In physics, you can't do away with two things. It's either you know your definitions very well or your formula. Now from the formula or from the definition or from the unit, we can get our dimensional symbol. So this meter, the dimensional symbol for meter, for length, is capital letter L. Then the dimensional symbol for this time, which is seconds, is T, capital letter T, raised to power minus 2. So that means I will now rewrite this G as L raised to LT raised to power minus 2, then all raised to power 1. Then this small L is length. We are going to change it to the dimensional symbol. So we just change it to big L. So the next line of action is to put this together in this series. So that means T is equal to, now I can rewrite this as L raised to power x times L, then this y, we multiply this L, that is what? L raised to power y, because from one of the laws of indices, h raised to power a raised to power b is equal to h raised to power ab. So you deal with this power like that. So L means L raised to power 1, then put the power to expand the powers. So y times 1, that is L raised to power y, then t minus 2 times y, that is t raised to power minus 2 y. So the next line of action, now what we are going to do here is comparing the coefficients or comparing the powers. But on the left hand side we are having t. So how do we make it up? So that we are going to have L on the left hand side. So that this t on the right hand side, we have a companion on the what? On the right hand side, and L on the right hand side, we have a companion on the left hand side. But from what we are seeing here, it's only T that is having companion on both the left and the right. What of L? So we need to improvise for L. How do we improvise for L? We can now rewrite this expression as L raised to power 0, then T raised to power, T means T raised to power 1, is equal to L raised to power x, L raised to power y. So this is product. I can use dot for product. I can use this. Then T raised to power minus 2y. So now you can see that if you say anything raised to power 0 in mathematics in indices, it's equal to 1. So what I'm just trying to do is just to make sure that this L on the right hand side have a companion on the left hand side. And anything raised to 0 is equal to 1. So another way of writing this is still this. So nothing has changed. I just want to compare the powers. That was the reason why I've used L raised to 0, which is L naught. So I will now compare the powers. So comparing the powers. So that means L naught is equal to, now using the first law of indices, recall that x raised to power a times x raised to power b equal to x raised to power a plus b. So I'm going to use the same concept here. So this gives L raised to power x plus y. So this is product, you operate it like this, then that implies that you equate the powers 0 is equal to x plus y. Call this equation 1. Then let's compare t on the left with the t on the right. So on the left, we are having t raised to power 1, and on the right, we are having t raised to power minus 2y. So comparing the powers on the left and the right, 1 is equal to minus 2y. How do we find y? We divide both sides by negative 2. So negative 2. So that means y is equal to minus 1 over 2. So y is equal to minus 1 over 2. And in equation 1, we are having 0 is equal to x plus 1. So we can from here find the value of x. So substitute minus half for y in equation 1. So anywhere we see y in equation 1, we are going to plug in minus half. So now we have 0 is equal to x, our y is what? Minus half. So if x is made the subject of the situation, this comes to the left hand side, that means half is equal to x, which also implies that x is equal to half. So hence, the value of therefore x is equal to half and y is equal to minus half. So that answers the first part of the question, because the question says find the values of x and y. We've successfully done that. We've determined the value of x and the value of y. Then the next question now says hence write the formula connecting t, l, and g. How do you write the formula connecting t, l, and g? You now come back to the origin. The origin says that t is equal to 2 pi l raised to power x, g raised to power y. So from this, at this juncture, we are going to substitute the value of x here and the value of y here to complete the solution. So we have t is equal to 2 pi l raised to power, what is our x? So our x is equal to what? It's equal to half. So l raised to power half, then g raised to power minus half. So what is the next line of action? In indices again, anything raised to power half is the same thing as the square root of that expression. So I can equally write l raised to power half as root l. So I can equally write g raised to power minus half as 1 over root g, because initially this is equal to 1 all over g raised to power half, which can equally be written as 1 all over root g. So hence t is equal to 2 pi, then l raised to power half will be replaced as what? Root l, then multiplied by g raised to power minus half is 1 all over root g. Then from mathematics again in the rules of sort, when you are having root a over root b, recall that root a over root b is equal to root of a over b. So similarly, I can now say that this particular t is equal to 2 pi into root of l all over what? Root of g. So hence the equation connecting, or the formula connecting t, l, and g is given as t is equal to 2 pi into the square root of l over g. So this particular, this is an interesting formula. This is the formula we use in performing simple harmonic motion that tells us the acceleration due to gravity of a particular place. Thank you. So that is the end of the solution. That is the end of this session. Life is always continuous. Life is differentiable. Life is integrable, but not Lebesgue measuring. It is a diet.